Okay, let's go. Okay. I lowered the height of my chair so I can sit properly. I think I've been sitting wrong for a long time just because the chair is so high. So my feet can't sit flat on the ground unless the chair is actually at a good enough level. Oh, glass is gone. Hmm. Hey, you could probably spend more time making an algorithm that generates a sequence of numbers that look less related to each other, more random as a pattern. Even though with the same seed, you'd get the same result. Because it's the initial value that all the other ones are deterministically created from. So, like, we could have one of them get a seed from the user and then get 10 numbers back from it, or let's say 20. Okay. And we'll do well, you could have it if it's not unsigned, you could just have it be 50-50. To be positive or negative. But how would you have it be 50-50? You'd need to randomly determine that. I'll make it unsigned first, just for implementation. Okay, so we'll get the seed from the user, and then we will output pseudo-random number generation. Okay. See if I can do that better. I could do select till home and then be good. Okay. So get a header file for, we'll just do all of this stuff. So we'll just call it PRNG. It's fine. Okay. What does it get user seed? Okay. And this needs to return an unsigned int because we're doing it unsigned at first. And then void, what is it? Output PNG. and then it needs to take an unsigned int, seed. Okay. We need an implementation file. This needs, does this need output? Yes. No, it doesn't. We'll do, let's see. We'll get the seed first. And then we'll call the function, and it'll have a static unsigned integer, which will be initialized as our seed. And then it'll get changed and never initialized. Well, yeah, so it'll only be initialized once and subsequent calls will not. Okay. So we're going to get the seed first, and then we're going to do a loop and then call it each time. So first we're actually going to do, oops, like this. I'm going to get the user seed, and this is going to be from this namespace. So first we'll do, we'll do this first. So we have this, and then this should be, what, also an unsigned int? So we're getting a seed from the user, and then we're calling a function that returns the modified version of that seed to generate a pseudo-random number. Okay, that sounds right. So unsigned int that takes an unsigned int. Or an unsigned int returning function that takes an unsigned int. And then we'll say for an integer called num of PRNGs. Oh, we want 20. Excuse me. First, we're going to do int current PRNG. And it's, we'll start with 1. And then we go through 20. So while current PRNG is less or equal to num of PRNGs, like this. And then we'll do, how about PRNG? Or we'll just say, yeah, or we'll just say get PRNG. Get PRNG from seed. Get, okay. And so here this is unidentified, and then that's it. Line 10 is whack because of this. Because it's expecting an operand. Okay. Or, oh, it's because this is a null expression right now. Okay. So now we'll do the implementation file. We'll just call it PRNG. Include the header file to resolve any type discrepancies for user error, or from user error. PRNG functions, I think it's called. Probably makes more sense to just copy and paste this. Okay, and from the user seed, this actually does need input to get user input. So it actually is needed in both spots because we're outputting stuff in here, but because we're going to be including this here, we don't need to include IOStream here. It's going to be transitively included, and we can do that now. I'm not going to do that until it's done though. And so here we'll have an unsigned int, and we'll just call it user seed. Its value initialized to 0, and then we're going to extract input from the user. User seed, and then we're going to, it's fine, we can just do it like this, and then return user seed. It's self-explanatory. Gets value from user, I'll just say user value, or we'll just say user seed. I mean, it's self-explanatory that it's user seed. I don't know, I like having comments just because even if it's a little redundant, it's like, oh, unsigned didn't get user seed, bro, just tell me just, well, no, I think it's better to be more fluent about what's happening here. Well, maybe it was a complicated function, so we'll just say gets unsigned int user seed. User seed, which is unsigned int, and here gets next PRNG from user seed. Okay. Returns next. Okay. And then here we'll go ahead and include it. PRNG functions namespace. Need PRNG functions namespace for PRNG. Yeah, just say that. Okay. Okay. It's undefined because we're not doing PRNG functions. Should be get user seed. Okay. Now we're not using the user seed because we have this value, this variable that we're not using. And then here we have some wonk because this doesn't do anything right now. Oops. Okay, now we're just not using the variables, which is fine. Okay. And in this case, we're going to have a static unsigned int, and it'll be called current PRNG. So at first it's value, well, oh, and it's going to be value initialized to be seed. And then we're not using that again, nor are we returning anything. And what we're going to do here, this is, okay. We could, yeah, let's update it. So current PRNG, which was 0 upon being created with program start, later initialized to be the value from user seed, which is this. And then we're going to update that value using the algorithm. So what is the algorithm? It is current PRNG times this number. We'll just make it odd because apparently even doesn't work. It's multiplied, and then we subtract some craziness, producing wraparound, and then we'll multiply it again. Okay. And honestly, this doesn't even look bad. We could say, okay, we have this value, we get it's whatever the seed is, and then later on, it's whatever the value already is, because it doesn't get destroyed between calls. It gets destroyed when the program ends because it's a static local variable. We're updating the current PRNG according to an algorithm. Okay. Okay. And then here we're going to output get PRNG from seed. And we're going to pass it user seed. Oops. Okay. And then we're going to tab it up. And then let's do 5 numbers per line. So if current number, which means the current loop count, if it's the 5th one, this is the end of the 5th one. If the remainder of its remainder with 5 is 0, end the line. Display 5 number PRNGs per row. Output next PRNG. Output all PRNGs. Okay. Oh, because the numbers were giant. Okay. We were getting 2 errors there. Oh. It's 2 from the same. Yeah. So if we convert it, we might get extra wraparound, which could be good. Okay. Yo. Is it happening? What is it doing? Oh. Okay. Oh. That'll do it. It didn't prompt the user. Should have known. Because the cursor was still there. Yeah. So dumb. Oh, and we could shrink the numbers too. This times this. And then remainder? I don't know what comes after. Remainder. Is it that times this remainder something? Or is it, I don't know. So instead of having to go and refer to operator precedence, I'll just do remainder 10,000. And we need to prompt the user. Okay. Okay. All the numbers are even. So what if we do remainder 9999? Oh, could it also been the number choice? There's a lot of nines. I guess there aren't. I just noticed nines more. And there happen to be a lot of eights here. Oh, but not really, because it's 8. And then, yeah, seems good. Okay. We've taken the user seed. Oh, and then we could test it. So we'll just do 1,000. First number is 2699, and then the second is 83 whatever. Yep. Same shit, because we have a deterministic algorithm. Makes sense? Yep. Yep. Okay. Which means it's probably good to not get these from the user. Or at least to vary it after getting it from the user. Actually, I don't know if that would matter, because it's all the algorithm doing the shit. Yep. Just as it would be if even if we didn't provide it, even if the user didn't provide it a value, there's some value that it starts with. Maybe that's 0, and then it just does something to 0 by adding. Then you might find that your numbers increase and then eventually decrease just because of wraparound. If you start at 0, you have to go up if it's unsigned. But I guess you could subtract and then you get higher numbers and then add, and then maybe it's not predictable whether it increases or decreases. It could probably still look random. Could probably still look random. Okay. Excuse me. Provided by the program, meaning that the program itself acquires it. Well, yeah. If Minecraft has a PRNG to determine where villages and things should be located, where biomes are, how large biomes should be, and it needs numbers that seem random-ish, but maybe it's a pain in the ass to make a real random one, or one that's approximating randomness. It acquires, it has to ask the user for something. Yeah, it makes sense. I mean, just like how a vending machine that gives the user a snack or a thing to consume is the same program that acquires the money. Makes sense. Yeah, I don't think it matters whether we oh, so the point here is that we're storing the seed globally like this. I don't know that I agree with this. So we have some global state and then it's not within a namespace. And then we're just seeding it because multiple things could be determined by the seed. And maybe there are a bunch of different generators that happen. Maybe there's one that just pretty randomly picks from 1 through 10, but then there's another that uses the same. So one input from the user, but different things. So maybe it makes sense to store it somewhere. Okay. Let's practice that. Or rather, what we could do is just call get user seed, stores the seed. Okay. And then we don't need to do any output here. We just have, we'll just do PRNG here as well. Then a little header guard action. Okay, and we could do G underscore because if it's just global, or we could just put it in PRNG values. I don't really like the G shit, but maybe it's okay because of the scope of the program. It's not big and multi-filed. No conflict worry, but I'd like to operate using best practices if possible. So we could say, this is the, oh yeah, this is the forward declaration too, so we should probably do extern. Because otherwise it thinks that we're default initializing this. Okay. And then we'll go ahead and get the implementation going on. Okay. But here, this part doesn't need to be extern because it's already a global variable because it's in a namespace, not a function. Okay. Okay. We'll value initialize it to be 0 until we use the function that seeds it. And it will be called void get user seed. Yeah, maybe. Is that a good name? Yeah, sure, it's done once. Okay. Void get user seed. Doesn't take any parameters, it just acquires shit. Okay. This is the header file, so we need iostream, need user input for user seed. We need output for PRNGs. Okay. And get user seed will, we've already included the header file to resolve any linker level type discrepancies between the for declarations and the definitions. Okay, we've now assigned the seed. Okay. And now we need to get the values, so we're going to display it, or we'll return rather an unsigned int, which is the current PRNG, and it is get current PRNG, or get next PRNG. and it takes an unsigned int itself. Oh. Yeah, it takes an unsigned int seed. Okay. And it just so happens that it actually uses the global seed. Okay. Can I now refer to that by name? No. We'll just say do I need to give it any parameters? Would it even make sense? Isn't the point, I think the point is to put it here. There were some best practices there before. Instead of just getting the value in the function, what did we do? Did we statically assign it? Or did we just update it? Oh, yeah, we give it a parameter. That way, if the parameter changes, we don't have to change the explicit logic here. So, like, if we did PNG values user seed, and then we updated it to be whatever with the algorithm, whatever, plus equals, blah, 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 whatever, some big crazy shit. Instead, if I later change it so that I don't want it to do the user seed, I want it to use the same algorithm for something else, I should be able to pass it something. So instead, we're going to say it needs an unsigned int seed, and then we're just going to pass it the value. That way we can pass the function stuff, and the function is more modular. Okay. Excuse me. Okay. So what we're going to do is the only thing here is if we pass it, we're going to be passing it as a reference or as a value, not by reference. Oh, that's because, so you do it this way when you're dealing with a constant. That way you can use a different constant later. But if you actually have to change the thing you're using, like, so if this is a function, let's say this is a function and it's called calculate force, and it needs a mass and an acceleration. Well, let's say we're talking downward force, and the only acceleration that we have is gravity. So we have a value, gravity. We put gravity in here as a parameter. That way, every time we call it, we're taking the value of gravity and copying it into this as an argument into this parameter. We are never changing gravity here. But in this case, because we actually want to update, well, actually, no. We're storing the seed once, and we're getting a static variable from it. So actually, we aren't going to change the seed. So Yeah, so we're gonna do make this guy const. But we can't do const expression because in its declaration, it is not known in its declaration. So we'll just make him const. Does that mean we could make him inline? I think it does. So we could instead make this a definition. And here the only issue is 15. Okay, because there's no semicolon. So far, actually, the get user seed is okay. And we're setting user seed. And we're including the namespace. And that namespace is known here, and it's actually defined here. Inline for const expression. So this actually needs to be inline. No, because we have to assign it, bro. It's not known at compile time. Ay, what am I doing? It isn't known at compile time. So nor can it be const. I'm just tripping here. Uh-oh, are we good? Extern. Oh. This needs to be a semi for declaration, not a definition. What was the error when it was being defined? Oh. Yeah. It needed to either see the definition or, like, what would happen if I just did not using? Yeah, so it saw that there's a parameter, but then saw that it wasn't being used, but the function wasn't being defined, and there wasn't a semicolon. So it wasn't being declared either. What was the issue? It's the implementation. Okay. Okay. So this guy is not known at compile time. So we can't do const expression. And it's extern. That way we can access it. Because we have to for declare it. And it can't be, it's not being defined here. Is there a reason for that? Couldn't I just make it inline? That way if this is included in multiple spots, it deduplicates this guy. He's not const. He's known, well, the compile time part doesn't matter, but it's not inline expansion. It's just, well, really the reason we would do it is care about it being inline? What are the benefits here? Or for declaring it and then having it elsewhere? Inline is so we can get the the reason for inline is to deduplicate the definition, and it has to be a definition to be const expression. It makes the most sense to just do. Let's bring him back. Just leave him extern and it's cool. He's not being defined here, he's being declared. Cool. Right here, he isn't being used, line 17. Because that's this function. Okay. So now what are we doing? Getting the next one. So we're taking the seed and we're just updating it. Oh, we have to multiply them by an odd number, I guess. We'll do that. So to multiply and add, do the remainder with 999. Okay. Okay, so we pass it whatever the seed is, and then we do that, and then we return. But in this case, we actually want we actually want this to be different. We don't want to just change the seed, because in this case, we'd get the same value each time. This guy isn't preserved between function calls. So we need another variable that is static. So we'll have static unsigned int current prng, value initialized to be 0. Or, so he's given 0, and then he's just initialized to be this. Oh, no, we want to do the assignment each time, because if we initialize him, he doesn't get changed. Because he only gets initialized to be, whenever this is called, he's initialized, and then he's never changed after. So this is the right way of doing it. But this time we'll do current prng. Oops, and this should be return current prng. And then here, we're just doing a loop. Current prng. And we'll say this is 1. And then, oops, this needs to be, we need a type. This is the loop count. And we'll do total PRNGs. We'll go 20. And we will go 20 while current PRNG is less than or equal to total, oops, PRNGs. And then we'll increment, why is it? Increment current PRNG. And then we'll do PRNG functions, get next PRNG. And then we'll do \t to tab it up. Output this PRNG. To output all PRNGs. And then if, oops, this needs to be inside the loop. Current PRNG, remainder 5 is 0, meaning it's divisible by 5, end the line. And okay. What was happening here? We didn't call the function properly. Get next PRNG, and this needs to be changed values. User seed. Uh-oh, it's the same thing every time. Oops. And the seed is not changing, so we will value initialize this guy to be the seed, and then we won't need him anymore, and then boom. Cool. Done. All right, so this time we have stored the seeding. So we store it as a global variable. We store some user input as a global variable. And then, can use that wherever we want. KO. All right, take a brain break.